I'll try to do the best I can here, so hopefully you guys can understand me. Let's go ahead and try to solve number 3 here. So starting from rest, the child zooms down a slide, height of 3, speed at the bottom. Same problem as the front, but this time friction does 200 joules of work on it. Okay, so same thing as before. Here's my slide. I don't end up on the ground. I end up a little bit above the ground. Label your initials and finals. Initial at the top of the slide, final at the bottom of the slide, but not on the ground. We're going to make a height of 0. What you make your height of 0 is totally up to you. I've been trying to mix it up and do different things, so I'm going to mix it up again, and I'm going to make the height of 0 the top of the slide. Okay, then we do our knowns and unknowns. So here's where we have to be careful. So our initial height. So if we're calling 0 the top of the slide, then the initial height is 0. It says it starts from rest, so the initial velocity is 0. We don't know how fast they're going when they get to the bottom, so that's just VF. And then the height final would be how far underneath. And if it's 0.5 above the ground and they start at 3 above the ground, then the height would be negative 2.5. And the mass is 17. Okay, just like we've been doing, we're going to find all our values. And these are all the things we're looking for here. So we need the work. It says there's 200 joules of friction. Now, friction does work against what you are doing. So that means it is 200 joules against, so it's negative 200 joules. It's something you need to be careful of. It's a really easy mistake to make, so just be careful. Then we're going to find our initial kinetic energy. Kinetic is 1/2 mv squared. Start from rest, so this would be 0. Initial mgh. And we start from rest. Or sorry, not from rest, we're starting at our height of 0, so that's also 0. Okay, then we do our finals. Kinetic final, I don't know what the velocity is, so I just leave it around, which just be 8.5 v squared. And the final potential, mgh, don't forget that because I called 0 the top of the slide, it's negative 2.5. Now, remember, you can call height 0 whatever you want. So just because I made the top 0 doesn't mean you had to. This gives me negative 416.5. Okay, so now that I've got all those, I'm just plugging them into the equation. So W plus KEI plus PEI equals KEF plus, or in this case minus, PEF. So add the 416.5 to both sides. Gives you 216.5 equals 8.5 v squared. Divide both sides by 8.5. Um, that gives me 25.5 equals v squared, and then finally just square root. And when you do that, you get 5.0 for the velocity. And if you look what we got on the front, this makes sense. So on the front where we ignored friction, we got 7 meters per second. And when we did not ignore friction, when we included friction, we got 5. So it's slower at the bottom, which makes sense because friction would slow you down. Okay? Hope that helps. Use that to help you with the rest of the practice you're going to do.